Hi guys, I'm going to be away this weekend, and I know that you're making Mathematica program, so here's a screencast that might help you out. Um, I hope that you try a different video than the one that I make, but this is the one that we were working on in class, where essentially you want to get two random variables. So we're going to get a random integer, and we want to get a random integer 1 through 52. So what game are we doing? Let's say that the game that we're doing is picking two hearts. All right, and so you'll notice that this notation, what I just did, is just a way to keep track of. It's a way for me to comment without the program acknowledging it. So we're going to do another random integer, and this random integer is going to be b, and we want to make sure that we pick two separate cards because we're going to not replace. So what we're going to say is while a is b, so if this is true, while a is b, we're going to assign a new variable to b. So this is just make sure that I get two separate cards. Okay, well now what? What we want to do is we want to see if they're hearts. So we're going to say that hearts are the numbers 1 through 13. Now our computer doesn't really know what a heart is, but we can just assign it numerical values. That's cool, isn't it? So what we want to see is if, well, if what? If A is less than 14, meaning it's a heart, and B, notice there's two ands, and B is less than 14, which means it's also a heart. That means we got two hearts. We're going to say success. We're going to give ourselves a success of 1, otherwise failure. So the if command says if this condition is true, we output this condition, otherwise we output the 0. Alright, so this is like dealing one hand. So if I press Shift Enter, notice that I didn't have any output, and I've got a red a red bracket there. That means I'm missing a bracket right here to close the while loop. So when I enter in this bracket, the red goes away. Nice. So now Shift Enter, and I get 0. And what that 0 means is that A and B weren't both less than 14, or in other words, I didn't get two hearts. So that would be like not getting two hearts. But I want to now repeat this over and over and over and over again, like a bunch of times. I want to deal like thousands and thousands of hands to calculate this this experimental probability. And this is what's so cool about computers, is that to deal thousands and thousands, 100,000 hands, it would take you a long time, but the computer can do it in less than a minute. So let's say like the number of deals that we have, we're going to start off with 0 deals, and we're also going to start off with 0 successes. So what successes are going to count is number of times I get, what do I get? I get 2 hearts. And the deals, this is just going to count how many total hands have I looked at. Great. So we've defined these new variables, and now everything in here, this is like one hand. So now I want to do a lot of hands. So when we want to do something a lot of times, that's when we're going to employ the while loop. So as long as deals is less than, how many times do we want to deal? Well, let's deal a lot. Let's deal 100,000 times. So as long as deals is less than 100,000, comma, I'm going to run this program. But then what I want to do is I want to make sure that this statement here, which checks to see if I got a success or not, I want to add this to I want to say my new number of successes equals my old number of successes plus this current hand. So this right there, that's my current hand. And maybe to make this a little clearer, it's the old number of successes added to my current hand. And when I say my current hand, like whether or not my current hand is a success or not. Well, great. Okay. So while deals is less than 1,000, that's up here. We're gonna do a hand. and we're going to check to see if my hand reveals a pair of hearts. Well, after I do that, what I want to do is to say, okay, well, I just did, that was a deal, so now I'm going to do deals plus plus, which adds 1 to my deals. So once this is going to add, it's going to say I've just done a deal, and then it's going to go back up to here and say, have I still done less than 100,000 deals? And if I have, we're going to run it again. So let's close the loop. Well, that's it. So now all I need to do is print it out. So what I'm going to do is print, so I'm going to print the probability of getting 2 hearts is, and then I'm going to do a couple spaces, parentheses, so it's just going to print whatever is in the quotations, or the parentheses, sorry, or quotations, and then comma, and now what I want to do is I want to print out, n is a command that converts a fraction into a decimal number, so I want to convert, well, successes divided by deals. So how many successes I got by how many deals I got. So I need to make sure that all my variables are called the same thing. So successes, successes. And then close this up, and now we're done. I just need one more bracket. See, if I didn't add that, this was red. This here was red, so I needed to add this. Okay, so now if I print this, Shift Enter, it says the probability of getting 2 hearts is blank. Now, unfortunately, that seems a little bit too low to me. Oh, no, that's right. I was just dealing with a different... I want to check that really quickly. So, binomial, there are 13 hearts, and I'm choosing 2 divided by 52 hearts, and I'm choosing 2. Let's get an approximation for that. So this should be closer to 0.05. What did we do wrong? Let's just change the success, success, success. Divided by 100,000. Okay, so now it should be running right. And you'll notice that this value here is close to that value there. Sorry, I defined some silly variables, but so this is your this is a program. Now I challenge you to create a different program because I just made this for you, and I don't want you to just copy mine. So maybe try to find the probability of choosing 3 hearts, or of choosing 2 kings, or of choosing face cards. Be creative. All right. Thank you very much for listening.